Hello and welcome, I'm your Code Monkey, and Unity sponsored this video to do an overview of their latest ebook all about the Universal Render Pipeline. This is a completely free ebook filled with tons of useful information. There's 126 pages covering everything from the absolute basics to some pretty advanced use cases. If you want to make your game stand out by looking their best and perform their best, then definitely you need to study this book. In this video, let's do an overview of some of the contents, but then definitely go ahead and click the link so you can study it in more detail for yourself. It's full of very useful info. I myself learned quite a few things, and again, it's completely free, so definitely check it out. There's timestamps in the video for everything we're going to see, starting off with how to create a URP project, then how to set up lighting and make it look good, how shadows work and all of its settings, what is light baking and dynamic objects, how to create reflection probes and lens flares, set up ambient occlusion, then explore some tools like shader graph and the VFX graph, how to interact with custom injection points, and a bunch more. All of that is covered in detail in this free ebook. But first, just a brief overview of what is URP and why it was made. Back when Unity started, it had just one render pipeline, which is now referred to as the built-in render pipeline, or BiRP. That render pipeline was pretty great and definitely allowed many excellent games to be made, but as technology advances and Unity supports more and more platforms, it was getting harder and harder to upgrade it and keep it performant. A lot of the parts on that system are essentially a black box where developers don't have much control and aren't able to extend in any way. So a few years ago, Unity introduced the concept of the scriptable render pipeline, and with it comes two presets, two render pipelines. One is the high definition render pipeline, which is all about pushing Unity to its visual limits, making games as gorgeous as they can be while focusing just on high-end platforms, so things like high-end PCs and consoles. And the other one is the Universal Render Pipeline, which, like the name implies, is meant to run on everything. So it runs on PC, console, mobile, web, literally every platform that Unity supports, all while being very performant and still looking pretty great. Nowadays, in most cases, you are recommended to use the Universal Render Pipeline. It's what I always use. And just to clarify, the fact that it isn't focused on the best visuals of all does not mean that it cannot look good. Quite the contrary, actually. URP can definitely look gorgeous. There's a ton of games that use URP and look really awesome. One example taken right from the cover of this ebook is Circuit Superstars. It's a really gorgeous looking top-down car game, all of the colors and the art style with all of the awesome effects like the depth of field. There's also Lost in Random, visually a very unique game, definitely stands out and again made with URP. Neon White is another great one, gorgeous clean visuals. And of course one of the main things about URP is the dedicated 2D renderer. So games like Tales of Iron use some gorgeous 2D art, as well as the very unique, very stylish Card Shark. All of those games are made with URP. So as you can see from these examples, if you learn how Unity URP works, you can definitely produce some gorgeous visuals. You just need to know how to use all of these tools and features that you have at your disposal, and that's exactly the purpose of this ebook, so let's dive into it. The book starts off with the introduction and talking about the rationale behind why make the Universal Render Pipeline. So it's pretty much what I mentioned previously. The built-in render pipeline was too difficult to modify, it was getting harder and harder to extend, so the solution was to make the scriptable render pipelines. Then like I said, this ebook covers everything from the absolute basics to some very advanced use cases. So over here on page 13, it starts off covering the conversion process. So how to create a brand new URP project or convert an existing project to URP. In case you haven't made a new project in quite a while, the Unity Hub nowadays is pretty excellent with tons of templates. So if you just click on New Project, over here you can see all of the various templates that it includes. For example, you can choose to start a 2D or a 3D scene using the built-in render pipeline, or you've got two presets for 2D or 3D using URP. Then you also got some really nice sample scenes, one in URP, one in HDRP, and so on. So from these you can start off with a completely empty project that is already configured using URP, or if you want you can start off with the very useful official samples to learn how it all works. Then the first very useful nugget of information is over here on page 13. Something you might not know about is the color space. Previously, Unity defaulted to the Gamma color space. Gamma is more performant, but it does not look as good. So unless you're targeting the absolute low-end mobile devices, then definitely make sure you're using the linear color space. To change that, you can just go into Edit, then go into your project settings. Then over here scroll into the Player tab. And then under these, if you go under other settings, over here you've got the color space. So you've got linear and gamma. Again, nowadays you should probably be using linear in pretty much every scenario. And then like I said, I've already learned quite a bunch of things from this ebook. For example, apparently there is a new scene workflow. Now usually for me I just duplicate an existing scene whenever I want to make a new one, so I literally have not used the file new scene in probably a decade. So I had no idea, but apparently there's a really nice template window. So if you just go into file new scene, and yep, here are a bunch of templates. You can start off completely empty, something basic with URP setup, or something standard which comes with URP, camera, directional light, post-processing, and so on. So for creating a brand new scene, this one would actually be excellent. Another thing you might not know are the various quality settings. When you create a new project with the URP template, it automatically creates multiple render pipeline objects, not just one. And the reason for that is to use different ones with different settings for each quality setting. So how you normally use URP is you go into Edit and you go into Project Settings. Then on the Graphics tab over here, make sure you have a URP asset selected. This is how you enable URP in your project. But then the second part that a lot of people probably don't know about is over here the Quality tab, where each of these qualities can have a different render pipeline assigned to it. If you don't assign any specific asset over here on this field, then it will pretty much just default into this one. Also, another thing you might not know about is the quality that is used over here in the editor. The one that is used is the one that you have selected over here on the Quality tab. So right now I have low selected, so it's using low, and if I click on high, yep, now it swaps to high. So in most cases in the editor, you really want to be using the max quality possible. Then for upgrading a project to URP, they've got a nice guide here on page 15. So the first thing you do is go into the package manager on Unity registry. Then you install the universal RP package. You create a new URP asset, either with the 2D renderer or the universal renderer. That creates two files. Then you go into the graphics tab and assign it. And finally, for the conversion process, there's a really nice helper tool under Window Rendering Render Pipeline Converter. So here, let's open up that window. So over here, the Render Pipeline Converter. Then up top, you can choose which mode you want. So built into 2D, upgraded 2D URP assets, or built into URP. So chances are this is the one that you're going to be using most of the time. And then here you can see these various sections, and the ebook explains all of them. The rendering settings creates all of the assets and assigns them. The material upgrade, this one changes the shaders to use URP shaders. Then there's a section for the animation clip converter. This is a bit of a strange one. I'm not entirely sure what this one does, since URP doesn't really have anything directly to do with animations. So I think this one just converts the legacy animations into mechanism animation, so not sure about this one. And finally, the read-only material converter. So this one is useful if you're using the included default materials instead of creating your own. Now for me, I use this tool all the time when importing any assets from the store. Usually they come with legacy standard shaders, so I need to open this up, set up built into URP, then toggle over here the material upgrade, initialize the converters, and convert all of them. That's what I always do whenever I import any asset packs. Then for the URP shaders, over here you can see all of the ones that are included by default, so what they do and how they differ from one another. Then here on page 22, there's a super useful table if you know something in the built-in render pipeline and you want to know what is the equivalent in URP. So for example, how to match quality settings and where each of these fields are. Then over here, you also have the quality settings when using URP. So some of these settings are set in the quality panel, whereas other ones are set in URP asset and so on. After that, we get into one of the most important topics, lighting in URP. Lighting definitely has a huge impact in your game. It doesn't matter how good your assets are, if the lighting is bad, they will look bad. So you absolutely must study this section to light your game correctly and make your assets look their best. Over here on page 35 is actually another thing that I did not know. So apparently for realistic settings, you should be using the lit shader, which does make sense, that one is physically based. However, they also mentioned that if the goal is for a more stylized render, then the simple lit provides great results. And over here we see all of the examples. This one is using the lit shader, so that's the one that's physically based. This one is using the simple lit, and this one down here using the baked lit. As you might know from watching my videos, I'm a big fan of the low poly look, which is very stylized, so perhaps I should be experimenting with using the simple lit shader instead of the regular lit shader. So there you go, yet another thing that I learned from this ebook. And of course, yet another mention of just how expendable the scriptable render pipelines are. If you want, you can also implement your own custom lighting model. Then over here on page 40, here's a quick walkthrough on setting up lighting in a new scene. So first you open up the lighting tab. That one is over here under Window, under Rendering Lighting. And now it pops up in this tab. Then you can create a new lighting settings. This one is an asset that contains a bunch of information for all the lights, all of this stuff. With it being an asset means that you can easily swap the asset for a different one and have completely different lighting settings per scene. The next super important topic is shadows, which also have a ton of settings. All of these settings are found in the actual render pipeline asset. One of the most important ones is over here, the one for the main light. The main light is usually your sunlight or your main directional light. For this one on the main light, you really want to enable shadows, so over here put it on per pixel and make sure cast shadows is ticked. And the next important setting is over here the shadow resolution. As you can see, you can go from really small to really big. So for mobile, perhaps you want to stick with the smallest values, maybe 256, maybe that's more than enough. And for PC and console, you might want to push it as far as 4K. Although again, higher resolution isn't necessarily better. So in the ebook, we have this really nice example. And here they are showcasing a more stylized cartoony scene. And here you can see the difference on the various resolution scales. For example, pay attention to the shadow over here that is being brought on by this little chair. So the shadow in there with 256, in there with 512, 1024, 2K, and 4K. In this example, you can see the one up top on 256. This one is way too blurry. You can barely see the shadow. Same thing over here for this box. However, on the other extreme, down here with 4K, with that, the shadow is way too crisp. So for a cartoony style like this one, you might want to go with something a bit smaller, perhaps just this, just 512, regardless if you're targeting a PC on console. So once again, another super useful bit of information. Then you've got the setting for the max distance, which is pretty obvious, but also something you might not know and might question why some of your objects don't have shadows. The answer is because they might simply be way too far. Now, depending on the regular distance of the objects to your camera, you definitely need to play around these values, the max distance. If your game is kind of like a super scale RTS or something like a God game, in that case you definitely need to increase these values. But again, also don't go overboard. Whatever distance you set will have to fit in the shadow texture resolution. So if you put a massive number, you're really just losing shadow quality for no reason. Over here we can see the difference between those two. In both of these examples, all the objects have shadows, but you can clearly see that the ones on the left, they've got some proper shadows, and the ones on the right are a blurry mess. The reason for that is because the ones on the right have way too big a distance, so all the shadows within a massive 400 unit distance, all of them must fit on that same texture. Then yet another super important setting that you might not know about are the shadow cascades. This is how you can define how much resolution to dedicate for each object based on distance. That way you can set so that objects that are close to the camera will have better shadows than objects that are far away. You set that over here on the render pipeline asset. Down here under shadows, you've got the max distance, and then you've got the cascade count, so you can modify this one, go from 1 all the way up to 4. And down here, you've got the various splits. You can play around all of these values to get the exact cascade shape you want. This one is definitely a super useful, must-use feature if your scene has a long shadow distance. Then on page 49, the book talks about light mapping or light baking. This is how you can bake super high quality lighting directly into your textures. The main benefit is that it's super high quality, and of course the downside is that it's static. So a dynamic player object moving through the world will not work with baked lighting. Basically, to make it work, the important part is that the objects for the environment are marked as static. Then on the mesh object you enable light map UVs, and on the lights you set them to either mixed or baked. When you do that, then on the lighting window you can enable bake global illumination, and then click on generate lighting. Now this entire subject, light mapping, this one is a massive thing by itself, so definitely go ahead and read the ebook to read all of these settings. And afterwards, go ahead and follow all of these links to learn much more about light mapping in general. It's a super useful tool for you to make your game's lighting look much more gorgeous, so definitely make sure you know about it. And related to that are the light probes over here on page 56. This is how you can sort of mix the high quality of baked lights, but also make them dynamic and super efficient. So over here on this scene using baked lighting, you can see that the player object is very well lit when outside and darkened when inside. The way this is achieved is by using these light probes. You basically just create a brand new light probe group, then you click the little gizmo button and position all the light probes. The important part is positioning them, so specifically place them where the light actually changes. Then when they are positioned, you just hit on bake, and each of those light probes will store their light value, and then when a dynamic object is moving through the scene, it will capture the light from the closest light probe. So this is yet another technique for making your games look and perform great. Then you also have reflection probes. Now by default, any reflective material will only reflect the sky. Reflection probes let you place probes in the world and calculate reflections from that point, which are then applied to all the reflective materials. So for example, on this sample scene, you would place one on the outside to reflect the outside world, and then you would make sure to place one on the inside so that the helmet actually reflects the inside of the hangar and not the outside while the player is inside. And then down here, here's yet another thing that I did not know, which are the various reflection methods and what they mean. Specifically over here, box projection, when should you use it or not. And apparently the difference with that one is that that one is based on distance. So as your character, for example, approaches the side wall of the hangar, you can actually see the wall getting closer in the reflection as opposed to always being within the same distance. Then on page 61 are the lens flares, so another thing that I don't normally use just because I never really bothered to research it, but apparently it's super simple. You'll literally just create a lens flare asset, then you add a lens flare component to any kind of light, and then just set up the settings. Super simple. Then on page 63 they mention my favorite effect, which I already covered in a dedicated video, screen space ambient occlusions. This one adds tiny shadows in the gaps between your geometry, so the whole thing looks much more grounded. Over here, look at the difference between over there, that object looks like it's floating, something for this one. Whereas down here with those tiny shadows, everything feels much more grounded. The section after that is all about shaders. Now, written shader programming is one of the game development things that I know absolutely nothing about. I've tried learning it, but it is so difficult. Thankfully, one of the tools included in URP is Shadergraph, so I can make awesome effects all without ever touching actual shader code. But if you do want to write custom shaders, then this section is super helpful. It contains lots of info on how to convert from built-in into URP shaders, lots of useful helper functions to help you, lots of types, and so on. So definitely go through this section in detail if you're used to writing custom shaders. Then we come to the pipeline callbacks section. This is a really advanced and extremely powerful feature. Like I mentioned at the beginning, this is one of the main benefits of the scriptable render pipeline compared to the built-in render pipeline. With this, you can basically hook onto various phases of the rendering process. So over here, you can inject the script in the middle of rendering shadows, on the prepasses, gbuffer, opaque, skybox, and so on. You can do that through code, but there is also a no-code workflow for injecting some custom rendering logic. You can go into the renderer and add the render objects feature. So over here, if you select the renderer, not the render pipeline asset, over here on add render feature, and you can add the render objects. Then here you've got tons of options to do all kinds of interesting logic without ever touching a single line of code. In the ebook, they showcase this nice simple example, which is how to see an outline even while the player is occluded, so whilst it's behind objects. For example, I used exactly this kind of logic in my house building system video. It's super useful and pretty easy to do thanks to this render objects feature. Another option, if you like using code, is over here on page 79, so you can create a C# script that hooks onto the rendering. This is another thing that I also experienced with, and I made a full detailed tutorial on how to make some custom post-processing. Over here they show very much a similar example to that. So you can create a C# script that hooks onto that part of the rendering pipeline, then you can use a shadergraph shader in order to do some kind of custom post-processing. Super useful. And also included in the ebook are a bunch of video tutorials made specifically for this ebook, so definitely check those out. And afterwards we get into the URP post-processing section, and they begin by mentioning the difference between the built-in render pipeline post-processing package and the URP post-processing volume. This is a pretty important difference, and I actually made a video explaining that difference. Basically, if you use the wrong post-processing and the wrong render pipeline, it won't work. Here they showcase how to add each individual effect and all of the settings on the volume component. For example, how you can make a local volume. This is how you can make sure that a certain post-processing profile is only applied if the camera is inside a certain area. One example where I used this was in remaking the mechanics from Verdun. I used a local volume to handle the gas post-processing. Then here on page 90, we've got a nice list of all the effects along with links to learn some more about them. Next, we see the section for additional tools that are compatible with URP. And of course, it begins by mentioning Shadergraph. So this is a tool for making shaders using a visual custom node-based tool. It's really awesome for people like me who can't really create shaders through code, and even if you can, Shadergraph is insanely powerful with tons of visual previews, so even if you can write some code, perhaps using Shadergraph might be better. I've already made tons of effects using it. It's a really awesome tool. So here they go through all the basics, what are the properties, the graph inspector, how all this works. The next super awesome tool is over here, the VFX graph. Now I made a video on this one, but I really haven't used it much since then. It's a really awesome tool for making particle effects that run on the GPU, meaning that it supports thousands or even millions of gorgeous particles in a super easy way. This is one tool that I really haven't touched on in quite a few years, so I definitely need to get back to this one and play around with it quite a bit more. Here on the ebook, they have a nice tutorial on how to make a really nice smoke effect. And of course, another huge thing about URP is the dedicated 2D renderer along with 2D lights. This is one thing that is simply not possible with the built-in render pipeline, so this one is a huge plus for 2D. Personally, I definitely wish that URP existed, and I had this back when I started working with Unity. My games are all in 2D, so I definitely would have benefited from this kind of 2D specific workflow. The 2D side of the engine has really improved massively over the past coming years. It's really great nowadays. And also about a year ago, they released a really awesome sample project called Dragon Crashers. It features pretty much all of the 2D tools, 2D lights, 2D effects, all of them in action. So if you want to see how to apply all of that and make something really gorgeous, definitely go ahead, download and inspect this project. It's called Dragon Crashers, there's a link over here. And finally, one of the most important sections, this one is all about performance. Now this one is full of interesting tidbits of information that can really help you achieve a nice smooth frame rate. There are many ways you can attempt to improve performance in your games. You can manage your lighting, you can use light probes, reflection probes, you can set up the camera settings, make sure the pipeline settings are all set up correctly, use the frame debugger to see exactly how the frame is being rendered, and of course use the profiler to see what are the hotspots in your game. All of this can help your game not just perform better, but also look better. Here's a pretty extreme example of using light probes. So the quality of this object is definitely much better than this object. Then how to be efficient with all of your reflection probes. How to use occlusion culling to not waste time rendering things that can't be seen. Learn how to use the frame debugger and identify each part of the rendering process to see what can be improved. And a bunch more things. So with that, we reach the end of the ebook. Over here on the final page, you can see a bunch of gorgeous games that were all made and rendered using Unity URP. So these are great examples of the kind of quality that you can achieve as long as you know how to use the tool correctly. Again, this video is meant just as a quick overview, so definitely go ahead and download the ebook, it's completely free. There's a bunch of things that I skipped just to make sure that this video isn't way too long. Things like light layers, which are super useful for highlighting specific objects. Also light halos, which is a simple but pretty great effect. How to control post-processing effects through code. How to work with camera stacking, which is how you can add cameras on top of one another. Like for example, you could make a second view, like a cockpit view on some kind of car game. So again, this ebook is full of tons of useful info, and again, it's all completely free. So check it out with the link in the description, and make sure you use the info in this book to make your game look the best it can be. Alright, hope that's useful. Check out these videos to learn some more. Thanks to these awesome Patreon supporters for making these videos possible. Thank you for watching, and I'll see you next time.